Hello and welcome to IT Conversations, a series of interviews, recordings, and transcripts on the hot topics of information technology. I'm your host, Doug Kaye, and in today's special program, I'm pleased to bring you a presentation from the O'Reilly Open Source Convention held in Portland, Oregon, July 26th through 30th, 2004.
Thank you. Well, you hope this talk is about you because the title of this talk is Great Hackers. It's probably about a lot of you, actually, if it's about anyone. A few months ago, I finished a new book, and I've been noticing in the reviews, I keep seeing words like provocative and controversial and idiotic. I didn't mean to make the book controversial. I meant to make it efficient. I didn't want to waste people's time telling them things they already knew. It's more efficient just to give them the diffs. But I suppose that's bound to result in a book people find alarming. There's no controversy about which idea is most controversial. No, it's not the one about French literature professors. Leading that is the one about the idea that variation in wealth might not be as bad a problem as we think. I didn't say in the book that variation in wealth was in itself a good thing. I said in some cases it might be a sign of good things. A throbbing headache is not a good thing, but it can be a sign of a good thing. For example, that you're recovering consciousness after being hit on the head. Variation in wealth can be a sign of variation in productivity. In a society of one, they're identical. And that is certainly a good thing, because if your society doesn't have any variation in productivity, it's probably not because everyone is Thomas Edison. It's probably because there are no Thomas Edisons. In a low-tech society, you don't see that much variation in productivity. If you have a tribe of nomads gathering sticks to make a fire, how much more productive is the best stick gatherer going to be than the worst? Factor of 2? Whereas when you hand people a complex tool like a computer, the variation in what different people can do with it is enormous. Well, this is not a new idea. Fred Brooks wrote about this in 1974, and the study he quoted was done in 1968. But I don't think he emphasized the point enough. He wrote about productivity in lines of code. The best programmers can solve a problem in 1/10 the time. But what if the problem isn't given? Imagination is hard to measure, but in practice it dominates the kind of productivity that's measured in lines of code. Productivity varies in any field, but there are a few, as you probably found in your own experience, where it varies as much as in programming. I don't think this is intrinsic to programming, though. I think that technology magnifies differences in productivity in any field, and that we in programming just have a lot of technological leverage. But in every field, the lever's growing, and so the variation that we see in programming is something that more and more fields will see over time. And the success of companies and countries and all kinds of organizations will depend increasingly on how they deal with it. If variation in productivity increases with technology, then the contribution of the most productive individuals will actually grow over time. If you reach the point where 90% of a group's output is created by 1% of its members, you lose big if something, whether Viking raids or central planning, drags their productivity down to the average. If you want to get the most out of them, we need to understand these especially productive people. What motivates them? What do they need to do their jobs? How do you recognize them? How do you get them to come and work for you? And of course, there's the question, how do you become one? I know a handful of super hackers, so I sat down and thought about what they have in common. Their defining quality is probably that they really love to program. Ordinary programmers write code to pay the bills. Great hackers think of it as something they do for fun, in which they're delighted to find people will pay them for. Great programmers are sometimes said to be indifferent to money. Well, this isn't quite true. It is true that all they really care about is doing interesting work. But if you make enough money, you get to work on whatever you want. And for that reason, great programmers are interested in making really large amounts of money. However, as long as they still have to show up for work every day, they probably care more about what they do there than how much they get paid for it. Economically, this is a fact of the greatest importance. because it means you don't have to pay great hackers anything like what they're worth. A great programmer might be 10 or even 100 times as productive as an ordinary one, but he'll consider himself lucky if he gets paid 3 times as much. As I'll explain later, this is partly because great hackers don't know how good they are, but it's also because money isn't the only thing they want. So what do hackers want? Like all craftsmen, hackers like good tools. In fact, that is a gross understatement. Great hackers find it unbearable to use the wrong tools. If you use the wrong infrastructure, they'll simply refuse to work on your project. At a startup I once worked for, one of the things we had pinned up on our bulletin board was an ad from IBM. It was a picture of an AS400, which I believe is a kind of computer, and superimposed on it were, I think, the words, "Hackers despise it." When you decide what infrastructure to use for a project, you're not just making a technical decision. You're also making a social decision, and this could be the more important of the two. For example, if your company wants to write some software, it might seem a prudent decision to write it in Java. But if you write your program in Java, you won't be able to hire as smart people to work on it as if you wrote it in Python. And the quality of your hackers probably matters more to the success of your project than the language you choose. Though, frankly, the fact that good hackers prefer Python to Java should tell you something about the relative merits of those languages. I mean, who wants to use a language where all the books look like detergent boxes? Business types prefer the most popular languages because they view languages as standards. They don't want to bet the company on Betamax. The thing about languages, though, is they're not just standards. If you want to move bits over a network, by all means, use TCP/IP. But a language isn't just a format. Programming languages are mediums of expression. I've read that Java has just overtaken COBOL as the most popular language. As a medium of expression, you couldn't wish, as a standard, you couldn't wish for more. But as a medium of expression, you could want a lot more. Of all the great programmers I know, I can only think of one who would voluntarily program in Java. Of all the great programmers I know who don't work for Sun on Java, I know of 0. Great hackers also generally insist on working on open source software, not just because it's better, but because it gives them more control. Good hackers insist on control, and this is part of what makes them good hackers. When something's going wrong, they need to fix it. You want them to feel this way about software they're writing for you. You shouldn't be surprised when they feel the same way about the operating system it's running on. A couple years ago, a venture capitalist friend of mine told me about a new startup he was involved with. It sounded promising, but the next time I talked to him, he told me that they decided to build it on Windows NT, and they had hired an eminent Windows NT developer as their chief technical officer. And I thought, these guys are doomed. For one thing, for this guy to become an eminent Windows NT developer, he would have had to use Windows NT voluntarily multiple times, and I couldn't see a great hacker doing that. 2, even if he was good, they'd have a hard time hiring anyone good to work for them if the project had to be built on NT. In fact, they did turn out to be doomed. They shut down a few months later. After software, the most important tool to a hacker is his office. To big companies, the function of an office is to express your rank. But hackers use their offices as more than that. Hackers use their offices as a place to think in. And if you're a technology company, their thoughts are your product. So making hackers work in a noisy, distracting environment is like having a paint factory where the air is full of dust and grit. The cartoon strip Dilbert has a lot to say about cubicles, and with good reason. All the hackers I know despise them. The mere prospect of being interrupted is enough to deter hackers from starting on hard projects. If you want to get real work done in an office with cubicles, you have 2 options. Work at home, or come in early or late, or on a weekend when no one else is there. Does this sound unfamiliar to anyone? Don't companies realize this is a sign something is broken? An office environment is supposed to be something you work in, not something you work despite. Companies like Cisco are proud of the fact that everyone there has a cubicle, even the CEO. But they're not so advanced as they think. Obviously, they still view an office as an expression of rank. Note, too, that Cisco is famous for doing very little product development in-house. They get new technology by buying the startups that created it, where presumably the hackers did have somewhere quiet to work. One big company that knows what hackers need is Microsoft. I once saw a recruiting ad for Microsoft with a big picture of a door. Come to work for Microsoft, the premise was, and we'll give you a place to work where you can actually get work done. And you know, Microsoft is remarkable among big companies in that they actually are able to develop software in-house. Not well, perhaps, but well enough. If companies want hackers to be productive, they should look at what they do at home. At home, hackers can arrange things themselves so that they can get the most done. And when they work at home, hackers don't work in noisy open spaces. They work in rooms with doors that are closed. They work in cozy, neighborhoody places with people around and somewhere to walk when they need to mull something over, not in glass boxes set in acres of parking lots. They have a sofa they can take a nap on when they feel tired instead of sitting in a coma at their desk pretending to work. There's no crew of people with vacuum cleaners that roars through the office every day during the prime hacking hours. There are no meetings or, God forbid, corporate retreats or team-building exercises. And when you look at what they're doing on that computer, you'll find it reinforces what I said earlier about tools. They may have to use Java and Windows at work, but at home, where they can choose for themselves, you're more likely to find them using Perl and Linux. Indeed, these statistics about COBOL or Java being the most popular language can be misleading. What we ought to look at, if we want to know what tools are best, is what hackers choose when they can choose freely. And if you ask that question, you find that open source operating systems already have a dominant market share, and the most popular language is probably Perl. Along with good tools, hackers want interesting projects. What makes a project interesting? Well, obviously, overtly sexy applications like stealth planes or special effects software would be interesting to work on, but any application can be interesting if it poses novel technical challenges. So, it's hard to predict what problems hackers will like, because some become interesting only when the people working on them discover a new kind of solution. Before ITA, who wrote the software inside Orbitz, the people working on airline fare searches probably thought it was one of the most boring applications imaginable, like data processing out of the 50s. Remember DP? That was what IT was called, like a few names back. But ITA made it interesting by redefining the problem in a more ambitious way. I think something similar happened at Google. When Google was founded, the conventional wisdom among the so-called portals was that search was boring and unimportant. But the guys at Google didn't think so, and that's why they do it so well. This is an area where managers can make a difference. Like a parent saying to a child, I bet you can't clean up your whole room in 10 minutes. A good manager can sometimes redefine a problem as a more interesting one. Steve Jobs seems to be particularly good at this, in part simply by having high standards. There were a lot of small, inexpensive computers before the Mac. He redefined the problem as, make one that's beautiful. And that probably drove the developers harder than any carrot or stick could. They certainly delivered. When the Mac first appeared, how many people remember when the Mac first appeared? My God, that changed my life. When the Mac first appeared, you didn't even have to turn it on to know it would be good. You could tell from the case. A few weeks ago, I was walking along the street in Cambridge. Something that used to be an economic necessity with me is now a hobby. I was walking along the street in Cambridge, and in someone's trash, I saw what looked like a Mac carrying case. I opened it up, and there was a Mac SE. So I took it home and plugged it in, and it booted. And there was the Finder, and the smiley Macintosh face in the Finder. You know, it was so simple. It was just like Google. Hackers like to work for people with high standards, but it's not enough just to be exacting. You have to insist on the right things, which usually means you have to be a hacker yourself. I've seen occasional articles about how to manage programmers. Really, there should be two articles. One about what to do if you are yourself a programmer, and one about what to do if you're not. and the latter could probably be condensed into 4 words. But I'll give you the 2-word version. Give up. Just in case there are any kids in the audience. The problem is not so much the day-to-day management. Really good hackers are practically self-managing. The problem is, if you're not a hacker, you can't tell who the good hackers are. A similar problem explains why American cars are so ugly. I call it the design paradox. You might think that you could have beautiful products just by hiring great designers to design them. The thing is, if you yourself don't have good taste, how are you going to recognize a good designer? By definition, you can't tell from their portfolio, and you can't judge from the jobs they've had or the awards they've won either, because in design, as in most fields, these things tend to be driven by fashion and schmoozing, with actual ability a distant third. There's no way around it. You can't manage a process intended to produce beautiful things without knowing what beautiful is. American cars are ugly because American car companies are run by people with bad taste. Incidentally, on the way here in a cab, I found I was behind a Pontiac Aztek, the only car since the Edsel that had to be canceled because it was so ugly Americans wouldn't buy it. And I thought to myself, wow, look at that. And then I looked down at the bottom and I noticed there was a Bush Cheney bumper sticker. I'm strictly politically neutral. Many people in this country think of taste as something elusive or even frivolous. Well, it is neither. It's as simple as this. To drive design, a manager must be the most demanding user of a company's own products. And if you have really good taste, like Steve Jobs does, you can make satisfying you the kind of problem that smart people like to work on. Well, it's pretty easy to say which kind of problems are not interesting to work on. Those where instead of solving a few big, clear problems, you solve a lot of nasty little problems. One of the worst kinds of projects is to write an interface to a piece of software that's full of bugs. Another is when you have to customize something for an individual customer's random and unspecified needs. To hackers, these kind of projects are the death of 1,000 cuts. The distinguishing feature of nasty little problems is that you don't learn anything from them. Writing a compiler is interesting because it teaches you what a compiler is. But writing an interface to a buggy piece of software doesn't teach you anything because the bugs are random. There's no pattern. So it's not just fastidiousness that makes good programmers avoid nasty little problems. It's more a question of self-preservation. Working on nasty little problems makes you stupid. Good hackers avoid it for the same reason that models avoid cheeseburgers. Of course, some problems inherently have this character, and because of supply and demand, they pay especially well. So a company that could get really smart people to work on really tedious problems would be very successful. Well, how would you do that? One place this happens is in startups, which is one reason startups kick ass. At our startup, we had Robert Morris working as his system administrator. That's like having the Rolling Stones play at a bar mitzvah. Strictly off the record, we also had him in charge of security. Merchants would say, will our credit cards be safe on your server? Don't worry, we have an expert in charge. He knows all about it. Damn, where was it? Yes. People will do any amount of drudgery in companies of which they are themselves the founders. Bigger companies solve the problem by partitioning the company. They get smart people to work for them by establishing a separate R&D department where employees don't have to work directly on customers' nasty little problems. In this model, the research department functions like a mine. They produce new ideas. Maybe the rest of the company will be able to use them. You may not have to go to this extreme. Bottom-up programming suggests another way of partitioning the company. Have the smart people work as tool makers. If your company needs to write software to do X, have one group that writes tools for building applications of that type, and then another group that builds the actual applications using them. This way, you might be able to get smart people to write 99% of your software and still protect them from actual users almost as much as they would be in a traditional R&D department. They would have users, but only the company's own developers. If Microsoft, for example, used this approach, their software wouldn't be so full of security holes because the less smart people writing the actual applications wouldn't be doing low-level stuff like allocating memory. Instead of writing Word directly in C, they'd be plugging together big blocks of word language. Duplo, I believe, is the technical term. Along with interesting problems, what good hackers like is other good hackers. Great hackers tend to clump together. Sometimes spectacularly so, as at Xerox PARC. What this means is that you won't attract good hackers in linear proportion to how good an environment you create for them. The tendency to clump means it's more like the square. So it's winner take all. At any given time, there are only about 10 or 20 places that hackers really want to work. And if you're not one of them, you won't just get fewer great hackers, you won't get any. Having great hackers is not in itself enough to make a company successful. It works for Google and ITA, which are two of the hotspots right now, but it didn't help Thinking Machines or Xerox. Sun had a good run for a while, but their business model is a down elevator. And in that situation, even the best hackers won't save you. I think, all other things being equal, a company that can attract great hackers will have a huge advantage, though. There are people who would disagree with this. While we were making the rounds of venture capital firms in the 1990s, several of them told us that software companies didn't win by writing great software, but by brand and dominating channels and doing the right deals. They really seem to believe this, and I think I know why. I think what a lot of VCs are looking for, at least unconsciously, is the next Microsoft. And if Microsoft is your model, you shouldn't be looking for companies that hope to win by writing great software. But it gets worse. But VCs are mistaken to look for the next Microsoft because no startup can be the next Microsoft unless some other company is prepared to bend over at the right moment and be the next IBM. I meant Microsoft spanked IBM. It's a mistake to use Microsoft as a model because their whole culture derives from that one lucky break. Microsoft is a bad data point. If you throw them out, what you find is that good products do tend to win in the market. What VCs should be looking for is the next Apple or the next Google. I think Bill Gates knows this. What worries him about Google is not the power of their brand, but the fact that they have smarter hackers working for them. So who are the great hackers? How do you know when you meet one? Well, that turns out to be very difficult. I'm pretty sure now that my friend Trevor Blackwell is a great hacker. Some of you may have read about him on Slashdot, about how he made his own Segway. The surprising thing about this project was that he wrote all the software in one day, in Python, incidentally. For Trevor, that's par for the course. But when I first met him, I thought he was a complete idiot. He was standing in Robert Morris's office, babbling at him about something or other, and I remember standing behind Robert, making frantic gestures to shoo this nut out of his office so that we could go to lunch. Robert said he was mistaken at first, too. Apparently, when he first met Trevor had just adopted a new scheme that involved writing down everything about every aspect of his life on a stack of index cards, which he carried with him everywhere. He just arrived from Canada and had a strong Canadian accent and a mullet. The problem is compounded by the fact that hackers, despite their reputation for social obliviousness, sometimes put a good deal of effort into seeming smart. When I was in grad school, I used to hang around the MIT AI lab occasionally. It was pretty intimidating at first. These guys all spoke so fast. But after a while, I learned the trick of speaking fast. You don't have to think any faster. Just use twice as many words to say everything. With this amount of noise in the signal, it's hard to tell good hackers when you meet them. I can't tell even now. You also can't tell from their resumes. It seems like the only way to judge a hacker is to work with them. And this is the reason that high-tech areas tend to start around universities. The active ingredient here is not so much the professors, but the students. Universities are like intellectual dating services. They bring together promising young people and make them work together on projects, and then they start new projects of their own. Because you can't tell a good hacker, except by working with them, hackers themselves can't tell how good they are. This is true to a degree in most fields. I've found that people who are great at something are not so much convinced of their own greatness as mystified at why everyone else seems so incompetent. But it's particularly hard for hackers to know how good they are because it's hard to compare their work. In the 100 meters, you know in 10 seconds who's fastest. Even in math, there seems to be a general consensus about what problems are hard to solve and what constitutes a good solution. But hacking's more like writing. Who can tell which of two novels is better? Certainly not the authors. With hackers, at least, other hackers can tell. That's because, unlike novelists, hackers collaborate on projects. When you get to hit a few difficult problems over the net at someone, you learn pretty quickly how hard they hit them back. But hackers can't watch themselves at work, so if you ask a great hacker how good he is, he's almost certain to reply, "I don't know." He's not just being modest, he really doesn't know. And none of us know, except about people we've worked with directly. Which puts us in a weird situation. We don't know who our heroes should be. Hackers tend to become famous by random accidents of PR. Occasionally I need to give an example of a great hacker, and I never know who to say. The first names that come to mind are always people I know personally, but that seems lame to use. So I think, maybe I should say someone famous, like Richard Stallman or Alan Kay or someone like that. But I don't know if these guys are great hackers. I've never worked with them on anything. So if there is a Michael Jordan of hacking, no one knows it, including him. Finally, the question... Sorry, what? Okay. Finally, the question the hackers have all been wondering about: how do you become a great hacker? Well, I don't know if it's possible to make yourself into one, but it's certainly possible to do things that make you stupid, and if you can make yourself stupid, you can probably make yourself smart too. The key to being a good hacker may be to work on what you like. When I think about the great hackers I know, one thing I notice is the extreme difficulty of making them work on anything they don't want to. I don't know if this is cause or effect. It may be both. To do something well, you have to love it. So to the extent you can preserve hacking as something you love, you're likely to do it well. Try to keep the sense of wonder you had about programming at age 14. If you're worried that your current job is rotting your brain, it probably is. The best hackers tend to be smart, of course, but that's true of a lot of fields. Is there some quality that's unique to hackers? I asked some friends, and the number one thing they mentioned, what do you think the number one thing they mentioned is? Curiosity. I'd always supposed that all smart people were curious, that it was just the first derivative of knowledge. But apparently hackers are particularly curious, especially about how things work. That makes sense because programs are in effect giant descriptions of how things work. Several friends mentioned hackers' ability to concentrate, not always in complimentary terms. Their ability, as one put it, to tune out everything outside their own heads. I've certainly noticed this. And I've heard several hackers say that after drinking even half a beer, they can't program at all. So maybe hacking does require some kind of special ability to focus. Perhaps great hackers can load a large amount of context into their heads so that when they look at a line of a program, they don't just see that line, but the whole program around it. John McPhee wrote that Bill Bradley's success as a basketball player was due partly to his phenomenal peripheral vision. Perfect eyesight means about 47 degrees of vertical peripheral vision. Bill Bradley had 70. He could see the basket when he was looking down at the floor. Maybe great hackers have a similar inborn ability. I cheat by using a very dense language. This could explain the disconnect over cubicles. Maybe the people in charge of facilities, having no concentration to shatter, don't realize that working in a cubicle feels to a hacker like having one's brain in a blender. Whereas Bill, if the rumors of his autism are true, knows all too well. One difference I've noticed between great hackers and smart people in general is that great hackers are more politically incorrect. To the extent there's a secret handshake among good hackers, it's when they know one another well enough to express opinions that would get them stoned to death by the general public. And I can see why political incorrectness would be a useful quality in programming. Programs are very complex, and in the hands of good programmers at least, very fluid. In such situations, it's helpful to have a habit of questioning assumptions. Can you cultivate these qualities? I don't know. But you can at least not repress them. So here is my best shot at a recipe. If it is possible to make yourself into a great hacker, the way to do it might be to make the following deal with yourself. You never have to work on anything you find boring, unless, of course, your family will starve otherwise. And in return, you'll never do a half-assed job. All the great hackers I know seem to have made this deal, although perhaps none of them had any choice in the matter. Thank you.
Thank you for listening to this special edition of IT Conversations. This edition was recorded at the O'Reilly Open Source Convention held in Portland, Oregon, July 26th through 30th, 2004. For more information regarding this and future O'Reilly conferences, visit conferences.o'reilly.net. This program is copyright 2004 by the presenter, O'Reilly Media, and RDS Strategies, LLC. My name is Doug Kay, and I hope you'll join me next time for another edition of IT Conversations.